Hello, Hornets. Thank you for joining me today. Today we're going to be working on our half angle and double angle identities. Now, before you begin, I recommend that you take a moment and you write down your formulas in a place where you can see them and work with them as you learn them. Now, on the test that you're going to be taking at some point, you do need to know your double angle formulas, but you can use your sum difference in order to help you to derive them. I will give you the half angle identities, so you do not have to memorize those. Please keep that in mind. Alrighty, so today we're going to start off, and I'm going to be doing the even problems that I have here. So if you wish, you can take a quick screenshot. You'll notice we'll be doing the sine of theta divided by 2. We have that happening in 2 and 4. We then have the tangent of theta divided by 2, and that happens in 6 and 8. Please be aware for number 8, it is going to be a more complex problem, so you will need to fasten your seatbelt as you go through it. All right? Let's go ahead and begin. So as we start, I'm going to write down that I am looking for, in number 2, the sine of theta divided by 2. I am told that the cosine of theta is 3/5, and I am told that theta is in quadrant 1. Now, when I do this, I'm going to set up my reference triangle in quadrant 1, and I would put in the hypotenuse of 5 and 3. Now, this really isn't necessary for this problem, and that's because when we use the formula for the sine of theta divided by 2, we know that we're using only the cosine value, as the formula is 1 minus cosine of theta divided by 2. Since we already know what the cosine of theta is, we are looking at the plus minus of 1 minus 3/5 divided by 2. This requires me to get the common denominator, and that will be fifths. So I will have 5/5 minus 3/5, the quantity, divided by 2. Now, the plus minus that we have out in front here, this is going to be based upon the actual angle. And we know that when we divide any angle between 0 and pi over 2, we'll actually get an angle that's going to be between 0 and pi over 4, the first quadrant. As a result, our ratio will end up being a positive. Now, as I do this, all I have to do is have 5 minus 3 divided by 5, and I'm multiplying by 1/2. Multiplying by the reciprocal of 2. I then get 2 divided by 10 inside of the square root, which ends up giving me 1 over, and the square root of 1 is 1, and root 10 in the denominator. Now, we do have to rationalize this in pre-calculus, so we're going to go ahead and call it root 10 over 10. And there is my first answer for number 2. As I continue, I'm now going to take a look at number 4. Number 4 says also to find the sine of theta divided by 2. I am given that the cosine of theta is root 2 over 2, and I'm told that theta is in quadrant 1, between 0 pi and pi over 2. Now when I do this, I'm looking at the same formula, plus or minus the square root of 1 minus cosine of theta divided by 2. Since half of our angle can only be in quadrant 1, we know we're dealing with the positive, and we are therefore looking at the square root of 1 minus root 2 over 2 divided by 2. This will give me the common denominator of 2 over 2 minus root 2 over 2, and I am going to multiply by the reciprocal 1/2. You'll notice I end up with 2 minus root 2 inside of the square root divided by the square root of 4. That's because when I get my common denominator, I end up with 2 times 1/2 and 2 minus root 2 inside of the radical. Notice I then take 2 times 2 is 4, and I square the numerator and the denominator, take the square root of the numerator and the denominator. I now have my answer, 2 minus root 2 inside of a radical divided by 2. And that's number 4. Number 6. Number 6 says find the tangent of theta divided by 2. And we know that our tangent of theta is negative 2, and it's going to lie in quadrant 2. So theta is going to be between pi over 2 and pi. Now, when we have something in the second quadrant, it is going to be in the upper half of quadrant 1, from pi over 4 to pi over 2. We know our formula that we can use, and I prefer the sine of theta divided by 1 plus the cosine of theta, and I need my reference triangle in the appropriate quadrant. So I'm going to find quadrant 2. Here is my angle theta. Here's my right angle. And tangent is the opposite over the adjacent. This, using the Pythagorean theorem, will yield 2 squared plus negative 1 squared, and I end up getting the square root of 5. That means that the sine of theta is going to be 2 over root 5, and the cosine of theta is going to be negative 1 over root 5. And I'm now going to directly substitute them. So I have 2 over root 5 divided by 1 plus negative 1 over root 5. Now this is going to allow me to change the sign in between into a negative, and I have 2 over root 5 divided by, and I need a common denominator, root 5 over 5, root 5 minus 1 over root 5. This then simplifies into 2 over root 5 divided by root 5 minus 1 over root 5. I now can multiply by root 5 divided by root 5, and the two denominators cancel. I'm now looking at 2 over root 5 minus 1. Now our problem with this is that we have a radical in our denominator, and we are forced to multiply by the conjugate pair to get rid of it. Now I wouldn't go ahead and distribute immediately, as it may not be necessary. Let's go ahead and find out. We have 2 times the square root of 5 plus 1, and when I do the difference of squares, I end up with 5 minus 1. This is giving me 2 root 5, so we have our parenthesis, 5 plus 1, and it's all over this over 4, which will allow me to reduce, and my answer is root 5 plus 1 over 2. Alrighty, let's go to number 8 as we just cruise along with our work. Now number 8 is not going to be a pleasant problem in that the number is large. We are looking for the tangent of theta divided by 2. We are given that tangent of theta is negative 8 over 17, and we know that we are looking at a theta that is in quadrant 4. So between 3 pi over 2 and 2 pi. We also know that our result is going to end up being a negative, as we are in quadrant 2 when we divide the fourth quadrant in half. I'm going to go ahead and set this up in the fourth quadrant. I have my adjacent, and my adjacent is going to be 17, and my opposite, again, here's our theta, here's our right angle, and we're looking at negative 8. Now, when I use the Pythagorean theorem of 17 squared plus negative 8, the quantity squared, I end up getting the square root of 353. I'm now ready to find my sine and my tangent, or my sine and cosine. The sine of this angle theta is going to have to be negative 8 over the square root of 353. The cosine of this angle is going to be 17, the adjacent, over the hypotenuse, 353. We're now going to put this into the formula for tangent. Once again, I'm going to use sine of theta divided by 1 plus the cosine of theta. Here we go. Negative 8 over square root 353 divided by our 1 plus 17 over the square root of 353. Now you'll notice we need a common denominator. So I'm looking at 8, negative 8 over the square root of 353 divided by the square root of 353 plus 17. And because they will both have the same denominator, I'm going to put it below both. I now can multiply by the square root of 353 divided by the square root of 353. And because I have a complex fraction, I end up getting rid of these two pieces. I'm now ready to continue. I know I have a negative 8. I know I'm multiplying by the conjugate pair, 353 to the square root minus 17, and it is all over. And let's just make sure we have 353, and notice I just squared. So I had a squared minus b squared, that's 353, and we have 17 squared. 17 squared is, 289? And if I subtract, I end up getting a 64. I have a negative 8, square root of 353 minus 17. Now remember to put your parentheses or you might make a mistake. The 8 will reduce, and I'm now looking at negative square root of 353 plus 17 all over 8. I'm going to go ahead and I'm going to write that over here now. Negative square root 353 plus 17 divided by 8. And I need to try to, frankly, I've got my radical out of the denominator. Everything is cleaned up. There's my answer. That's what I'm looking for. Let's go ahead and move on. Notice that was a fairly ugly problem. Number 10. Number 10 is asking us to use the half angle identity, and we have the cosine of 105. You need to know your reference angles. You need to know your unit circle for this. So I'm looking at my cosine of 210 divided by 2, and I now know that I have a negative because it's in the second quadrant. I know that I have my 1 plus the cosine of 210, and this is divided by 2. So I'm going to simplify this and just keep going. I have 1 plus, I need the ratio of a 30-degree angle reference angle, that's root 3 over 2 in the third quadrant. So it's a negative root 3 over 2. And I am still dividing it by 2, getting the common denominator. Square root 2 over 2 minus root 3 over 2, the quantity is divided by 2. That means it's going to multiply in the next step. We end up with the square root of 2 minus root 3. The 2 reduces with the denominator, and I do have a minus out in front. And this is my answer to number 10. Alrighty, this brings us to number 12. Number 12 has the tangent of 22.5 degrees. That means that I'm looking at the tangent of 45 degrees divided by 2. Now we know what our tangent can be. I once again like the sine of our 45 degrees divided by 1 plus the cosine of 45 degrees. Putting it together, I get root 3 over 2, root 2 over 2. Whew, getting tired, people. Root 2 over 2 divided by 1 plus root 2 over 2. Now I'm going to get the common denominator. Root 2 over 2 divided by 2 over 2 plus root 2 over 2. If I multiply the top and the bottom by 2, I get rid of the denominators from the numerator and the denominator. Notice that I now have something that's a lot simpler to work with. I have root 2 divided by 2 plus root 2. And all I have to do is get rid of the radical by multiplying by its conjugate. Remember, what you do to the bottom of the fraction, you have to do to the top. Alrighty, we're now going to go ahead and start multiplying. We have a 4 minus 2 in the denominator. I have a 2 root 2 minus 2. Since I end up with a 2, I can factor out this 2, leaving me with the square root of 2 minus 1, and the 2's will reduce. Therefore, my answer is the square root of 2 minus 1. Alrighty, let's keep going. We're going to go to number 14. Number 14. We are looking at our angle, 67.5 degrees. And they've told me that this is my sine function. Let me put that sign in front of that. Actually, yep, 14. So I have the sine of 67.5, and I'm going to double it to find out what it is. So 67.5 times 2, and okay, I'm getting little hokey things here. Let's try that again. So I have 67.5, and I'm multiplying by 2. There we go, 135 degrees. Once again, we're looking at sine is in the first quadrant, so we know we're looking at a positive square root. And in order to deal with sine, I have 1 minus cosine of 135 degrees divided by 2. I'm now going to replace what is the cosine of 135 degrees. I am looking at a negative root 2 over 2, and the double negative applied. I'm multiplying by the reciprocal of the denominator, and I know it's a square root. So, common denominator is 2 plus root 2 all over 2 times 2, and that's going to give me a 4. I then have the square root of 2 plus root 2 in the numerator and the square root of 4 in the denominator. I end up with root 2 plus 2 root 2 divided by 2. And there is my answer. Let's go ahead and go to number 16, please. 16 is now giving us radians. So we have the cosine of 5 pi over 8. Now, once again, we're just going to double the numerator and clean it up, and it's going to give me the cosine of 5 pi over 4 divided by 2. Now I'm going to put in my formula for cosine, the square root of 1 plus cosine theta, or cosine theta divided by 2. We know it's a plus because this is in the second quadrant, and when we take half the second quadrant, we get the upper part of the first quadrant. So here we go. We're going to now plug it in. What is the cosine of pi theta over just theta? Cosine of theta, excuse me. We have 1 plus. We know it's a negative root 2 over 2, and we are dividing by 2. Common denominator gives me 2 over 2 minus root 2 over 2, and I'm multiplying that by 1/2. Now I'm going to have to simplify, and I get the square root of 2 minus root 2, and the square root of 4, which is 2. And here we have number 16. Now I'm going to leave you through the rest on your own, as I'm going to the back to do the couple of the evens, 22, 24, and 26. Alrighty, here we go. Now we're looking at having a problem that says that the sine of alpha is 3/5. Alpha is between 0 period and 0 degrees, excuse me, and 90 degrees. Been a long week, Hornets. All right. Now we know that in our double angle formula, we're trying to find the cosine of 2 alpha. And we know that the cosine of 2 alpha that we can use is going to be the one that involves the sine function, since we already have the sine function. And that is 1 minus 2 sine squared of alpha. My answer ends up being 1 minus 2, 3/5, the quantity squared. Notice I now have tenths. So I have 10 tenths is 1 whole minus 2 times 9. And then I have time, let's make sure we get this 25 in there. So we have the 2 times the 9 over the 25. Alrighty, notice I can't use that 10 over 10. I want to, but 1 is going to have to be 25 over 25. I end up getting 25 minus 18 over 25. And lo and behold, I get 7 over 25. This is my answer for that double angle identity. Let's keep going. So we're looking at number 24. Number 24 tells us that we have tangent of alpha, and the tangent of alpha is 3/4. We are told that theta is in between, or alpha is in between the 0 and 90 degrees. And I'm going to need to find the information because I already know that my double angle formula that I want to work with tangent is either, let's just go 2 tangent of my theta, and I'm dividing by 1 minus tangent squared of my theta. Now we know what tangent is, so I'm going to go direct substitute. 2/4 multiplied by a 2 divided by 1 minus, and now we can put in 3/4 the quantity squared. Now I want to keep the fourths for a little bit, so I'm looking at 2 times 3/4 divided by, and now I need to get this into the common denominator of, looks like it's going to be 16ths. So I have 16 16ths minus 9 16ths. This is giving me 6 divided by 4 times 16 over 16 minus 9. Once again, I got a common denominator and I took the reciprocal and multiplied. I can see that this is going to reduce down to a 4, and I'm now looking at 6 divided by, and I get 7. So 6/7 is the answer that I'm working with. And I hope this is making sense. This brings me to number 26. This is our last one that we are doing, at least that I'm doing with you today. I hope this is helping you. And if it isn't, you're going to want to come in and get some additional support. All righty. Here we go. We are told that the cosine of alpha is going to be 4/5. All right. We are then told that the unit circle goes from 270 degrees, and then we're going to go up to 360 degrees. We're trying to find sine of 2 alpha. All right, our formula is 2 sine alpha cosine alpha. And I only see the cosine of alpha. So I'm going to need to go into the third quadrant and try to determine what I have. I have a 5, I have a 4, I have a negative 3. So therefore we know we're dealing with negative 3/5 is the tangent of our theta. So here we go, is let's see. So this would be our sine, yes. Now I'm going to put it into my formula. Let's see, we have 2, I hope I did that right. I am just looking at my information and what I'm trying to find. Cosine of 4/5, and we know it's going to be, okay, so I'm at number 26, so that's what's happening. I got lost a little bit. It's again a little late, so I'm just trying to put my information in. I know that I have cosine in the fourth quadrant, which is going to be 4/5, and I know that I have a negative 3/5 in the fourth quadrant. This is giving me 20/5, and I have 8 times 3 is negative 24. So negative 24 over 25 is the answer for number 26. Alrighty, Hornets. I hope this has helped you. Please be aware we will continue to practice this as we move on to our sum product and sum identities on Monday. We'll then have our pretest on Tuesday, and after that we will have our test on Thursday. Thank you very much. Be well and take care, and we'll see you all later. Bye-bye. Cheers.